Hello everyone, welcome back to lecture 34. This is part 2. So, this is the part of module 10 and we were talking about the drought, right. So, I hope you remember that we started discussing about the mitigation measures, and here we had this crop rotation, contoured row crops, terracing farming, tillage practices. This is what we have discussed in the first part. Now, we will continue with this erosional control structure, water retention and detention structures, reclamation of salt affected soils. So, when we talk about this erosion control structures, so immediately you will have some figures in your mind how to store the water which is available on the surface. So, engineering measures differs with location, slope, soil type and amount and intensity of the rainfall. Commonly used engineering measures are contour bunds, trenches or stone walls. Then we have check dams, then we have percolation ponds. These are very popular and commonly used in many of the areas. So, this is the example of contour bunds. So, here you can see this is how it looks on the ground, right. Then check dams, then you have percolation ponds. So, these are manually designed, right. Some of them are natural, but we are using them. Now, we will talk about the preparedness phase. So, the early warning and readiness, the strategic stockpiling of cereal and grains, that can be one of the strategy, rehabilitation of critical boreholes, livestock marketing, animal and human health support, supplementary feeding of livestock, right. So, now you can just go back and just remember the ENSO, right. How important it is to know about the ENSO. If you have prior information, maybe the farmers can use the appropriate crop type in their area, so that there won't be very high loss during this drought period, or they can utilize some appropriate measures so that the less amount water can lead to the high yield, right. In water resources, increased water storage by locating new potential resources, increase groundwater recharge by construction of small scale water collection or harvesting systems, adjusting legal framework to help people, artificial precipitation, that is one of the area, but it is not currently working, desalination of groundwater especially in the coastal region, saline water treatment, reuse of wastewater or recycling, etc., right. And when we talk about the demand management, reduction in uses and losses. Once we know that our area is about to receive less amount of water in this particular area, then we can restrict the people to use less water and save water. Water allocation policy. So, during the drought condition, maybe the industries which are using the water which are not required or which is not in the primary list, they can be stopped for time being, or the less amount of water can be supplied. Monitoring and forecasting system, surface groundwater storage review, adopting reviewing water tariffs, sensitizing and awareness campaigns. These are different measures. Now, when we talk about this adopting or reviewing the water tariff, that helps because once you increase the tariff, maybe if I am using 100 liters a day, maybe because of the increased tariff, I will definitely go with the minimum amount which is required, right. So, in that case, everybody will try to save the water directly or indirectly or maybe forcefully. Then supply augmentation, mixing of fresh and low quality waters in supply, exploiting high cost water or the deep water, locating new resources for emergency, provide permission to exploit additional resources, provide drilling facility that will help the people to directly extract the groundwater, improving demands management, this is for the agriculture, water loss reduction irrigation scheme, shift to less water demanding crop and cropping system, research of drought tolerant crop and species, proper fertilization and pest management, no till or reduced tillage system, crop rotation or cropping system that definitely helps, seeding rate or density, soil preparation, etc. Then immediate response will have the animal and human health interventions, emergency water supply system, supplementary feeding for vulnerable groups, then restoration and stability, restocking livestock, rehabilitation of dams, infrastructure development, food for work and cash for work programs, natural resource management interventions, right. Now, we will talk about the reconstruction and long term sustainability. Focus on rebuilding and strengthening resources post drought, includes continued infrastructure rehabilitation and capacity building, ensures future drought resilience through natural resource management, integrates lessons learned to improve preparedness and mitigation effort, because some of the areas are regularly experiencing this drought condition. So, we have some example and we have some learning from the past event, and that can be used to plan our future. Slow onset duration ranging from month to year with large spatial coverage. So, here you have meteorological, this is because of the rainfall deficiency, hydrological because of the surface and groundwater deficiency, agriculture it is because of the soil moisture and rainfall deficiency, right. And the key variables are climate data, soil moisture, stream flow, groundwater, reservoir and lake levels, vegetation health, stress and fire danger. And there are many earth observation missions which are launched and where their data sets can be used in drought analysis. Slowly we will learn about this, right. So, here you can see one example of satellite image utilization in drought analysis. So, this is from June, July, August, September, October, and this is the normal, this is mild drought, moderate drought and severe drought. You can see how areas are falling under different category. Rainfall and temperature, that is one of the major criteria, and we know that satellite images are the main source nowadays for the rainfall and temperature data sets. Rainfall is measured using gauzes and satellite based estimation methods with meteorological department issuing forecast. Analyzing daily, seasonal and annual rainfall fluctuation helps in understanding drought trends. Temperature influences evaporation and plays a crucial role in drought assessment, with deviation indicating climate change. So, we have to keep checking the area's parameter, how the area is moving towards drought, because this takes time to develop, right. Evaporation and evapotranspiration, it is one of the major parameter. Evaporation from open water body depends on radiation, surface temperature, wind speed and humidity, right. It varies across region with higher evaporation rate in arid zone. Evapotranspiration includes both evaporation and transpiration and impacting water availability and drought severity, right. Then comes the soil moisture. Soil moisture is the top layers of soil, determines crop growth and yield. It influences water and heat exchange between land and atmosphere. Measurement methods include weight based techniques, microwave sensor and lesimeters, right. Reservoir water levels and river flow. We all know many of the rivers and the lakes or the reservoirs have the continuous measurement of the water level, right. Surface water availability in lakes and reservoir depends on rainfall, snow melt and consumption. Governments assess previous drought events before regulating water releases. River flow between stations help to determine groundwater contribution and potential drought severity in a particular region. Crop area and yield assessment, that is also important, because ultimately this agriculture drought is going to affect the whole population, right. Directly or indirectly we all are getting affected. So, here the vegetation health reflects water availability and drought intolerant plants wilt or die. Ground based and remote sensing method assess crop health and shrinkage in vegetation cover, that you can easily do with the remote sensing data set. Drought related crop failures leads to economic challenges, food shortage and price fluctuation. So, this will directly impacting our country's economy. Climate, which is one of the important parameter. Precipitation deficit, for example, during a specific stage of crop, growth season or by location. Temperature, average, maximum, minimum, amplitude, all these can be derived. Evapotranspiration can be measured, soil moisture can be measured and other hazards can also be monitored, so that we will be able to assess the drought condition in a given particular area. In water resources, reduction in runoff, spring discharge, temporary rivers, snow melt, these are the different sources. Water storage, the percent of the reservoir filled, groundwater recharge, wells discharge reduction, percent of dried well, drawdown etc., that helps you to assess the condition. Water allocation used by different sector for drinking water, for industrial uses, for household uses, for agriculture we can calculate and we can release as depending upon the availability of the water in our storage. In agriculture, how do we evaluate? Irrigated and rain fed areas, failures or delay in crop germination, plant density, onset of growth phase or stages, crop yield, these can be monitored and we can assess the or evaluate the drought condition of a particular area. Then comes the livestock. So, reduction in range and pasture land production and quality, estimate of quantity or supportive capacity per unit area, vegetative cover, dominant species or the quality, reduction in total livestock, reduction in forest production like timber, charcoal, wood, forest fire and other drought associated hazards. So, these will help you to assess the drought condition in livestock. The characteristic of droughts are expressed in terms of drought index and intensity, duration, frequency. So, if you see this particular graph, here you can see that there are two colors used. One is orange, which is drought period, and the blue is non-drought period, right. So, the blue you can see what is the intensity, right, and what is the duration. This is duration. So, if the duration is large like this one, this is a non-drought period, but if you refer to this drought period is quite long, right, this is quite long. So, in such situation problem will be more, right. So, introduction to drought indicators, because we understood the basics of drought, what are their characteristics, what are the different types of drought, how do we mitigate and how do we evaluate. Now, let us see how we can identify them. So, we will talk about the drought indicators. Drought indicators simplify complex information and helps in decision making by assessing the severity and impact of drought. So, let us say just verbally, if I say this area is going through or experiencing the drought. So, if I say a particular area is experiencing the drought condition, but how will you interpret this statement, whether it is severe, whether it is in the beginning phase, whether it is normal. So, for that we need to have some kind of drought indicator which will inform or which will be used by the policy making people or the decision making people, and they will be able to mitigate or help the local people, right. It provide a quantitative basis for monitoring changes in agriculture production, groundwater level and social cost. An ideal drought index should integrate biophysical, economic and social data. Since drought risk is influenced by meteorological, socio-economic and technological factors. A well designed index allows comparison of present day risk with future projection, helps policy makers preparing for increased drought occurrences, right. So, this is very important to evaluate, to identify. So, we will be talking about the indicators. Indicators are essential for detecting and monitoring environmental and social changes caused by drought. They provide a basis for designing disaster risk reduction policies and evaluating their effectiveness. Establishing region specific threshold ensures that drought risk assessment reflect market, climate and socio-economic conditions. Early warning system depends on reliable indicators to predict drought severity and support mitigation strategies. So, we have some drought indices. Drought indices should be universally applicable across different terrain and agroclimatological zones. So, when we are trying to develop a drought indices or drought index, it should be applicable not only for a given area, it should work for the any given area. They must be versatile, adapting to various severity thresholds and scales for national and regional analysis. Easily interpretable indices supported by readily available data improve drought response planning, because your developed drought index should be very simple to use and it should use the data which is available in public domain or which is easily accessible, right. So, then only you will be able to see the effectiveness of this drought index. These indices should assist farmers with land use planning and future scenarios projection. So, ultimately we need to inform the farmers and then our situation will be managed. Key components of effective drought indices. A good drought index must consider accumulated water deficit rather than simple deviation from average condition. Daily time steps are essential, as a single day's rainfall can significantly impact water balance. Indices should account for both soil moisture and other water storage resources such as lake and groundwater. Time dependent relaxation functions help to track the lasting impact of past rainfall event. So, we need to evaluate the situation. Drought triggers are based on threshold values that defines when management actions should start or stop. These triggers specify time period, spatial scale, drought level and whether conditions are worsening or improving. So, we need to keep on monitoring all the parameters. Drought levels are characterized into mild, moderate, severe and extreme to guide management decisions. A well-defined index helps to coordinate drought response and resource allocation efficiently, because ultimately what is our aim? We have to mitigate and help the people, right? Because we cannot stop drought, because this is a natural phenomena and you have seen the ENSO. We do not have any control over that. So, what we can do? We can only try to reduce the severity of the impact. So, we need a indicator. Advances in drought monitoring requires improved indices that integrate meteorological, hydrological and agriculture factors. The use of satellite data and machine learning can enhance the accuracy of drought prediction. Future indices should incorporate socioeconomic and climate change projection for better long-term planning. Strengthening early warning system with improved indicator can mitigate the adverse effect of drought on vulnerable communities. So, if a particular community is more vulnerable to this drought, then the government has to focus on them only. As we discussed, drought index integrates rainfall data, surface runoff, snow cover and other water supply indicator, that is input to the area. A drought index is typically a single number, but far more useful than the raw data for decision making, because once you get the number, let us say it is 0 to 1, 1 is the severe impact or severe condition of the drought, and maybe 0.5 is moderate and 0 is the normal condition. So, if your drought index is saying that this particular region has the value of 1, that means you have to focus on that particular region immediately, and that area needs immediate help, right? There are several indices that measures how much precipitation for a given period of time has deviated from the average precipitation. This average precipitation is basically historically identified. Most water supply planners find it useful to evaluate one or more indices before making a decision, because for some area maybe a particular drought index, maybe let us say this is drought index 1 and then we have drought index 2, right. So, this 1 and 2 both will be used, and then probably the decision making will be much more easier. So, we will not be biased. So, there are different drought index. So, first one is the percent to normal precipitation, PNP. Then we have a standardized precipitation index, we call it SPI. Then we have PDSI, this is Palmer Drought Severity Index. Then we have Surface Water Supply Index, SWSI. Then we have Reclamation Drought Index, and then we have decile, that is monthly drought calculation. These drought indices are very popular, and you will find many literature explaining these methods, right. So, with this I will end this lecture 34, and we will continue this drought in the lecture 35 in the next lecture. Thank you very much.